Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first three parts of the quadratic equation where I have covered many concepts like sum and product of the roots, nature of roots, graphical representation of a quadratic equation, and so on. So if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to do some problems of quadratic equation based on the concepts that we have learned in the earlier videos. So let us start with today's video. Let us start with this question today. If m and n are the roots of the equation x² plus 7x plus 6 equals to 0, then find the quadratic equation whose roots are, the first one is m plus 1 and n plus 1, and the second one is m cube and n cube. Well, before looking at the solution, I would request you to solve these questions from your end first and then to check the solution. So, m and n are the roots of the quadratic equation x² plus 7x plus 16 equals to 0. And we need to find the quadratic equation whose roots are m plus 1 and n plus 1 and m cube and n cube. Well, the first thing that we can do is find the roots from this quadratic equation, which would give us the value of m and n. And then for the first one, we can find m plus 1 and n plus 1. And from the second one, we can find m cube and n cube, from which we can find the quadratic equations. But if you observe here carefully, for this quadratic equation, discriminant d would be simply b square minus 4ac, that is 7 square minus 4 into 1 into 16, which would be 49 minus 64, so that would be minus 15. Since the discriminant here is negative, so we'll be getting imaginary roots. So if we find the imaginary roots, we'll be getting the value of m and n, and then we need to find m plus 1 and n plus 1 for the first one, and we need to find m cube and n cube for the second one. Well, this approach would be too much time consuming, and it is not advisable to go via this method. Rather, we have one shortcut method to solve such kind of questions. We know that if we have the sum and product of the roots of a quadratic equation, we can write the equation as x square minus sum of roots into x plus product of roots equal to 0. So let us try to use this to find the quadratic equation for the first and the second part. Since m and n are the roots of this quadratic equation, so we can write sum of the roots, that is m plus n, as minus b by a, which would be minus 7 upon 1, that would be minus 7. And the product of the roots, that is m into n, would be c by a, that is 16. Now, for the first one, the roots are m plus 1 and n plus 1. So the sum of the roots of that quadratic equation would be simply m plus 1 plus n plus 1, which would be m plus n plus 2. Now, m plus n, we know this is minus 7, so this would be minus 7 plus 2, that would be minus 5. In a similar way, we can find the product of the roots of that quadratic equation, which can be written as m plus 1 times of n plus 1. Now, if we expand this, this would be mn plus m plus n plus 1. Now, let us use the value of m plus n equals to minus 7 and m into n is 16 in this. So, this would be 16 plus minus 7 plus 1, which would give us 10. So, for the first one, the quadratic equation would be simply x square minus sum of the roots, so that would be minus 5x plus product of the roots, that is 10, equals to 0. So, this would be x square plus 5x plus 10 equals to 0. In a similar way, for the second one, the roots are m cube and n cube. So the quadratic equation whose roots are m cube and n cube, in that case, the sum of the roots can be written as m cube plus n cube. And we know that the formula for a cube plus b cube is given by a plus b whole cube minus 3ab into a plus b. So let us try to use this formula here. So this can be written as m plus n whole cube minus 3mn times of m plus n. So let us now use the value of m plus n and m into n. So m plus n is -7. So -7 cube would be giving us -343 minus 3. M into n is 16 and m plus n is again -7. So if we simplify this, this would be -7. Again, the product of the roots of the quadratic equation whose roots are m cube and n cube would be given by simply m cube into n cube, which can be written as m into n whole cube. So this would be 16 cube, which would be 4096. So the quadratic equation whose roots are m cube and n cube can be written as x square minus sum of the roots, which would be -7 into x plus product of the roots, which is 4096 equals to 0. So this would be x square plus 7x plus 4096 equal to 0. So we can directly use x square minus sum of the roots into x plus product of the roots equal to 0 to solve such kind of questions. Now let us see this question. Find the range of values of p for which the quadratic polynomial x square plus px plus 9 have two distinct real roots, equal roots, no real roots. Well, to find the range of values of p for which we'll be getting distinct roots, equal roots, or no real roots, let us try to take the help of the discriminant of a quadratic equation. Here, the quadratic polynomial is x square plus px plus 9. So if we compare it with the standard form of quadratic equation, in that case, the value of a would be 1, the value of b would be p, and the value of c would be 9. So the value of discriminant b would be simply b square minus 4ac, which would be p square minus 4 into 1 into 9, which would give us p square minus 36. Now, to find the distinct real roots, we know that the discriminant would be greater than 0. So that means p square minus 36 would be greater than 0, which would give us p plus 6 into p minus 6 would be greater than 0, as a square minus b square is a plus b times of a minus b, and 36 is 6 square. So p plus 6 times of p minus 6 is greater than 0, which would give us either p greater than 6 or p less than -6. So the range of values of p for which the quadratic polynomial x square plus px plus 9 have two distinct real roots would be p greater than 6 or p less than -6. In a similar way, for the quadratic polynomial x square plus px plus 9 to have equal roots, the discriminant d would be equal to 0. So that means p square minus 36 would be equal to 0, or p square would be 36, which will give us p to be plus minus 6. In a similar way, for this quadratic polynomial to have no real roots, the discriminant has to be less than 0. So that means p square minus 36 has to be less than 0, or p plus 6 times of p minus 6 has to be less than 0, which will give us p in the range of -6 to 6. So if p is greater than 6 or if p is less than -6, in that case, this quadratic polynomial will have two distinct real roots. And if p is plus 6 or -6, in that case, this quadratic polynomial will have equal roots. And if p is lying in the range of -6 to 6, in that case, this quadratic polynomial will have no real roots. So to solve such kind of questions, we can simply take the help of the discriminant. Now let us see this question. Find the quadratic equation with leading coefficient 2 and 7 plus 6i as one complex root. Well, one thing we have learned in the previous video, that if one of the root of a quadratic equation is a complex root, then the other root will be its conjugate pair. So if one of the root is 7 plus 6i, in that case, the other root would be simply 7 minus 6i. So the two roots of the quadratic equation are 7 minus 6i and 7 plus 6i. So the sum of the roots of that quadratic equation would be simply 7 plus 6i plus 7 minus 6i, which would be 14. And the product of the roots would be simply 7 plus 6i times of 7 minus 6i. So this would be a plus b into a minus b, which would be a square minus b square. So that is 7 square minus 6i whole square, which would give us 49 minus 36 I square. And we know that I square is given by -1. So this would be 49 plus 36, which would be 85. So the quadratic equation would be given by simply x squared minus sum of the roots, that is 14 into x, plus product of the root, that is 85, equals to 0. But in this question, it has been given that the leading coefficient is 2. So we need to multiply this quadratic equation by 2 to get the leading coefficient as 2. So if we multiply this by 2, then this would be 2x squared minus 28x plus 85 into 2 would give us 170 equals to 0. So this is the quadratic equation with leading coefficient 2 and 7 plus 6i as one complex root. Now let us see this question. If the roots of the quadratic equation 5x squared plus 3k minus 1 into x minus 4 equal to 0 is of same magnitude but of different sign, then find the value of k. We know that for a standard quadratic equation, that is ax squared plus bx plus c equals to 0, if the roots are of same magnitude but of different sign, in that case the sum of the roots would be 0, which indicates that the coefficient of x, that is b, is equal to 0. In a similar way, for this quadratic equation, if the roots are of same magnitude but of different sign, in that case the coefficient of x would be 0. So that means 3k minus 1 would be equal to 0, which would give us 3k equals to 1 or k equals to 1 by 3. So the value of k has to be 1 by 3 for this quadratic equation to have roots of the same magnitude but of different sign. In a similar way, if it has been given that for a quadratic equation, the roots are reciprocal of each other, in that case, we can directly use a equal to c. That is, the leading coefficient and the constant term to be equal. Now, let us see this question. Find the quadratic equation whose roots are 2 more than the roots of the equation x squared minus 8x plus 4 equal to 0. So if we assume alpha and beta to be the two roots of this quadratic equation, in that case, we need to find a quadratic equation whose roots would be alpha plus 2 and beta plus 2. So now this question becomes similar to the first question that we have done today. So we can solve this simply by using the sum and product of the roots. So for this quadratic equation, the sum of the roots, that is alpha plus beta, would be minus b by a, which would be 8, and product of the roots would be alpha beta, which would be c by a, that is 4. So a quadratic equation whose roots are alpha plus 2 and beta plus 2, then the sum of the roots would be alpha plus beta plus 4, which would be 8 plus 4, that is 12, and the product of the roots would be simply alpha plus 2 times of beta plus 2, which would be alpha beta plus twice of alpha plus beta plus 4. So this would be 4 plus 2 into 8, that would be 16, plus 4. So this would be 24. So the equation would be simply x squared minus sum of the roots into x, so that is 12x plus product of the roots, that is 24, equals to 0. So this is one way to solve such kind of questions, but there is also an alternate and an easy way to solve these questions. To use that, we need to simply replace x with x minus 2 in this equation. So replacing x with x minus 2 in this quadratic equation, we will be getting x minus 2 whole square minus 8 times of x minus 2 plus 4 equal to 0. So now if we expand this, this would be a square, that is x square minus 2ab. So that would be minus 4x plus b square, so that is plus 4 minus 8x minus minus plus, and e to the 16 plus 4 equal to 0. So if you simplify this would be x square minus 4x minus 8x would be minus 12x plus 4 plus 16 and plus 4. So this would be 24 equal to 0. So we can see that simply by replacing x with x minus 2, we are getting the same quadratic equation which we have got in this way. So if the roots are 2 more than the roots of an equation, we can simply replace x with x minus 2 to find the required quadratic equation. In a similar way, if the question would have been find the quadratic equation whose roots are 2 less than the roots of the equation this, in that case, we would have replaced x with x plus 2 to find the required quadratic equation, and so on. Well, if you want to know the reason why by replacing x with x minus 2, we are getting the required equation, you can let me know in the comment box. I'll make a separate video on that, as it will be requiring more explanation to understand it clearly. But for the time being, you can simply remember that to solve such kind of question, we can simply replace x with x plus minus 2 or whatever the number has been given to get the required quadratic equation. In a similar way, if the question would have been find the quadratic equation whose roots are reciprocal of the roots of the equation this, in that case, we can directly replace x with 1 by x to find the required quadratic equation instead of going through sum and product of the roots. Now, let us see this question. Find the maxima point and the maximum value of the quadratic polynomial fx, which is minus 3x squared plus 7x plus 4. Well, here the leading coefficient is minus 3. That means the leading coefficient a is less than 0. So the graph of this quadratic polynomial would be something like this, that is a downward parabola. So we'll be getting a maxima point and we'll be also getting a maximum value. And we know that for a standard quadratic polynomial ax squared plus bx plus c, the maxima point x is given by minus b upon 2a. So if we compare this standard quadratic polynomial with this quadratic polynomial, in that case, the value of a would be minus 3 and the value of b would be 7. So the maxima point for this quadratic polynomial would be simply x, which would be minus b upon 2a, that is minus of 7 upon 2 into minus 3, which would be 7 upon 6. So that means this quadratic polynomial will attain a maximum value at x equal to 7 by 6. So the maxima point is 7 by 6. Now, to find the maximum value, we can directly put x equal to 7 by 6 in this quadratic polynomial, which will give us the value of y to be minus 3 into 7 by 6 whole square plus 7 into 7 by 6 plus 4. And if we simplify this, the value would be 97 by 12. So the maxima point for this quadratic polynomial is 7 by 6 and the maximum value is 97 by 12. So we can directly use x equal to minus b by 2a to find the maxima or minima point, and we can use this value in the quadratic polynomial to find the maxima or minimum value. So that's it for today's video, in which we have seen some questions based on quadratic equation. But I would request you to practice some more questions, because the more you practice, the more you learn. And this video also brings us to the end of quadratic equation topic. I hope you have learned something through these videos, but if you have any confusion, you can watch the videos again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of the queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.